Hi everyone, Alex is here, and today we'll be talking about WebGL. So what is WebGL? WebGL is a library. It calls Web Graphics Library. And basically, when we have been working with all the websites that are now modern, and you can see there's 3D effects, it's WebGL. So let's talk about a little bit the story and more what is that. So as you can understand, WebGL is rendering interactive 2D, 3D graphics inside of your web browser. Before, for example, WebGL, what we had? We had Flash, we have Java, and we have Silverlight. These libraries, I think that you have seen them, especially Flash. You always should update their plugin. All of the games online, they have been using that one. That's all because how does it work? So in general, an idea of that is that we had some low-level code that have been used in processors to work with that in browsers. And it was working. That's all. It wasn't very productive. It was really hard. There was a lot of problem with capability. There was a lot of problem with security, because those things could be really easy to be taken. So that's why we have WebGL. And WebGL was created to work with 3D as native for browsers. So it's just using, it's using your video card directly to work with it. So it's a low-level solution for that one. And that's why it was created, because Flash, Silverlight, and Java was really hard to work on that. So WebGL was created. But we have a problem here. Even it was created, it's interesting to work with it, 3D games and etc. We still have a problem that there are not a lot of such applications. It was quite hard to work with that. So what do we have? We have threejs. What is threejs? Threejs is a library, and right now it's de facto your WebGL, and de facto is the #1 solution to create all the 3D effects. Why? Let's talk about it. Let's talk when it was created by Ricardo Cabello, or Mr. Dub, in 2010. So his main idea was to show and create a library that will be able to work with 3D graphics in web browsers really easy, because there are a lot of developers, even me, who don't understand so much at graphic design. So this library should just help us to easier work with this. So we shouldn't fully understand these graphics. We can use simple library to work with that. So that's why it was created. So threejs is basically the same WebGL, but it's just upper level API that just help you to write one method, and it will automatically run a lot of WebGL code that you should not understand, and it will take a lot of time to you to understand. So that's amazing that we can have a solution to one upper level that can make most of the things, and even more lower. So if we should have some specific changes, we also can do that. So that's the things that you should always remember on. So that's the difference in WebGL and threejs. And right now, once more time, threejs is just de facto the thing when you will be using for creating 3D or 2D interactivity. So we have more solutions. We have Babylon, we have Play. One second, I really forgot how this is called. It calls something with Play. Maybe I'll find it, maybe not. Okay, I really missed that. In any case, there are 3 libraries, and really our threejs is the most powerful from all of them. So that's what we are using right now, and we will be using for, I think, the nearest future for sure. And Where we can find that? You can find that in interactive visualization of the data, even 2D graphics, online games, of course. Even if you will see a lot of enterprise websites, for example, with their working with the maps, with some 3D, all that is Three.js for sure. So especially if you're working with building, so you have a website, you probably will be using Three.js to show how you have all of that. So that's naturally how does it work. Also electronic commerce, science and education thing. For example, we have been working with Arduino, not Arduino, on Voki, if I'm not mistaken, website. So that's the same Three.js. Like these things where you can see something, you can check the sphere to rotate that, all of that things. That's the thing. And also wish we have the future of that. Right now, for exchange of WebGL, we're having WebGPU. So it's even more low-level solution to work with your virtual video card. So it will help us to work even creating more complex animations and web pages with the design. So Three.js, I think, will help that and will fully go to the standard. It just will be new API for working with that. So it will be more effective because it will be even lower. And also we are going to WebXR. So what is WebXR? It's AR and VR. So for working and creating default experience with your AI and VR, we'll have in WebXR. It's also the standard for these things. And one more time, WebGPU that will be held by WebGU and Three.js will take a lead on that. So they will have really better optimization. So even right now, we can make that online. We can check our 3D elements, even on AR, VR. So all of the things you can really use it. And also on Amazon, you can check that. So that's quite popular right now, especially after Apple has released their solutions for AR some years ago, and that they will be taking a lead on that in physical sphere, something like that they thought. Yeah, so all of that experience right now is held in with WebGL and Three.js. And let's discover how we can make it in practice. Which code we can write so it will work in this way. And this is quite easy. I hope that you'll understand it. You like how this works. So to work with that, we can just go to our index.html file. And we only have here body and canvas. That's all, nothing really complicated. Then we'll be clicking right click and clicking open with live server. So if you have extension live server, it will be easier for you to work with that. So let's go further. We have also our Main.js, and here what will be the most interesting thing. So it's the easiest way that I can show you how this Three.js is working. So we can go to our website and see how does it work. So that's the result that we see. It's just a block that is rotating in the different directions, a green one. That's nearly all, and we can also click and inspect so you can see it based on the difference on the size. So we can change the size. It also will change here. So how does it work? Let's check it out here. We have importing our Three.js model. So we're just going here. So as you can see, it's quite easy. Like it can be even taken from here. We can take also min version, so that will be even better. And you can check how does it work from the scratch. I don't know that if everything will be understandable here, but yeah, that's what it is using. So let's go down and let's understand deeper how does it work. So we're creating scene, so that's the place where we'll have everything. So all the black canvas with the thing, with the cube, it's all scene. Then we have this perspective camera. What is perspective camera? It's where what we are seeing, because we can put this place in the different directions. So understand that cube and your camera, they can be in the different places, so they're not linked to each other. And this thing helps us to work with that. Yeah, so I'm back to tell you what is 75 and this values. So 75 is our Angle of view. So with different angle, we will see that from the different angle of what we see here. So it's just like rotating your head to different directions. This one is just saying what will be our height and width in the middle, like just we're taking width and height and dividing that, not to have any deformation. So like we have seen the cube is really square, but we can see that as not rectangular, like more wider, for example. That's because of the deformation, so this thing won't make any deformation. This is minimal distance, this is maximum distance that camera will have based on your web, like of your size of web application, like your screen. So that's what is render do. Render will run your virtual card to take that on its size. So because we can render that not on the GPU, so it will be rendered that on on our graphic card, so it will be faster. So that means that we are running our graphic card that you'll be mostly using. Then for rendering, we are setting the size for our of that canvas, of that block. So then inside of the body, we're putting our render and DOM element. That DOM element is basically our everything that we'll have inside of our render. So then we're creating the cube. So it is the size of that. So it's basic size, and it depends on how close you to it. So you can change these things, or you can change these things to be far away or closer. This one and one will be different. So that's why we don't have a lot of the pixel sizes. We have just numbers. Then you can check that with your distance, and you can make it smaller or higher. Then we have mesh basic material. That's just the color that we have in the hex format. So we'll be using, as you see, green material, and that's all. And for creating the cube, we're using our mesh, so it's our material. For that, we're taking our geometry and material, and we're creating the mesh. So basically, geometry and plus material, so our color, sometimes it's a skin or something like that, plus the geometry, in our case, it's cube, it can be round, something, create like these two things being added, and we have cube. Because we can just have, for example, something sphere here and color red, for example. If I'm not mistaken, it's like this one. Yeah, you can see. So by combination of material and geometry, we have an object. An object is our mesh. And all the things that are like upper level API of WebGL. So WebGL is, for creating such things, it will be much harder. And for our scene, so as one more time, scene is all of these things we're adding the cube. And where it will be on the position 5, we can make it 1, and you can see how close this one thing. We can make it far away, 10, like that. One more time, you should play with it to understand what effect you want to have. Then we have animate. What is animate? Animate is like, what do we see here? requestAnimationFrame, that's a method that JavaScript has, so it depends on your monitor, but in general, it refreshes every 1 second 60 times. Yeah, so that's how it works. That's why it's very great done. So it's very beautiful working. That's why we are using our requestAnimationFrame. And we're taking animate, so we're taking the same method, so it means that it will rerun every time. And then we have cube X and Y, so it means that every time our X and Y will be changed, so it will be rotating, as you see. And then we're putting our render, our scene, and our camera. Like, we're re-rendering all the stuff, because if we won't do that, it won't be changing and we won't see anything at all. So every time we should re-render our scene. That's how it works. So then we click on animate, so we're running that, and then it will be running every time. And then when we have resize, we're changing aspect ratio of our camera that we have seen here, so it won't be deformed. So the cube will be really cube, not something else. and update project metrics. So based on all that information that we have, it will update our metrics because our aspect ratio was changed. And then we have the render size different, because if we won't do that, for example, we'll be able to see the same square, even like the same all the thing, even with inspect. So we have inspect, and it will still be as it was before, higher, and the cube was to be down, more to the center of this block, not of inspect. So that's this resize is working. So once more time, these things create scene, camera, and rendering based on your graphic card. Then based on what do we see on our website, size and height, width, we're setting the size for our rendering and then putting in the body. What we have then we're creating a cube. So for creating the geometry box, you should have your geometry for an element, and you should have material for that. After that, you just should add it to your scene, and then you should be able to put your position, because that will help you to see an element or not. Then we have animation, and remember that requestAnimationFrame is just very often changes of your monitor based on your monitor. So it just, some monitors can make 120 updates per second, 160, so it depends. And this thing works automatically, so mostly use this one for really smooth animations, not set interval. This will be better. Then we have a cube that is rotating, so x, y, as you can see, because of these changes, it's just rounding. And then every time we should render our scene with our new information. If we won't be doing that, we'll be putting it here. You'll see what you will have. We'll have just the first frame, and you can see it a little bit here because it was changed for 001. That's all. It's even not a value, points, like something like that. That's how it works. Thanks everyone for watching this video. I was really happy to see you here, and I hope that this time you fully understand how does all of that things works, how does your WebGL works, why do you need that, and what will be profit for you to use such thing. Hope to see you in the next videos. Please write me your ideas, what you would like to see, or even tell me how do you like this background rather that I'm mostly using. Yeah, I really hope to see you the next time, and wishing you all the best. Bye.